Hello everyone, my name is Oleg Barbin and I'm a data scientist at Fonterra, a New Zealand-based dairy company. The aim of this talk is to give an overview of how we use JUMP to assist us in planning organic milk production. With Fonterra being the largest dairy exporter in the world, we manage a uniquely varied product portfolio, giving rise to challenging and interesting planning requirements. We'll start off by covering what the problem we're trying to solve is and why it's important to get it right. Without getting into too much detail, we'll talk about the solution approach we took to solve the problem. And lastly, we'll go into the unique benefits that using JUMP has brought to the table. So, imagine you had a cow that produced standard boring milk. That one cow makes 10,000 liters of milk a day, and it's your job, as a production planner, to decide what to do with that milk. Let's say, because pizzas are very popular, you need to make a lot of cheese. And after that, you decide to make a large amount of probiotic yogurt, some whey protein, and some low-fat milk. Before you go to sleep, however, you decide to upgrade your cow, and the next day your cow gives you 12,000 liters of milk. Because people cannot eat any more pizza compared to yesterday, you decide to allocate your extra 2,000 liters of milk to yogurt production, which can still be sold at a nice premium. The main thing to take away from here is that the day-to-day production decisions can be made largely independent of what happened the day before. Compare this to the life of an organics production planner. Because this is extra special organic milk, your one cow only makes 100 liters of milk compared to 10,000. So if you try to replicate the same production profile, you will run into issues where some production runs, such as protein powder and skim milk here, are too small scale to feasibly start a factory for. In fact, there are common situations where a whole day's supply of organic milk is not enough to start a factory, even if the entire supply is allocated to just one product. Now, how would we get around this problem? The way this is solved now is by a standalone planning process for organic milk, separate from the rest of the business, done manually. First, you generally have more than one organic milk pool available, and some of these may be nested within one another. For example, organic milk that passes USA certifications can be used both for American and European markets. In each day, you need to allocate the correct amount of each type of milk from farm to one of several factories, figure out if a factory should be started, or if we need to collect more milk the next day before starting the factory, and ensure that the product being made satisfies both existing orders and general demand trends. When this is being planned manually, the most difficult part of the process to figure out is this decision point here, where we're trying to collect enough milk to actually start the plant. Currently, it takes a single person up to a day to come up with a feasible plan for 3 months. This is a clear and enticing opportunity to implement an optimization-based planning solution. If done well, it will enable Fonterra to reduce the time it takes to generate a plan, freeing up the organics plan to make more strategic decisions rather than just trying to get by, allow portfolio growth in terms of number of viable milk pools and quantity of products we can manufacture, and improve plant quality through lower operating costs and higher organic milk utilization. So how did we model this? Our general goal and approach was to basically build a tool to make life easier for the company when it comes to planning organic milk. There are 3 key inputs into the model. How much organic milk do we have available? What are the minimum and maximum factory run sizes, as well as any other factory constraints? And what should we be making? With this information, we can use a mixed integer program approach to find a daily feasible plan that achieves a balance between optimizing production costs and using up as much organic milk as we can. Some of you may realize at this point that this problem is starting to look like a unit commitment formulation, where we have to commit our factories to a day of production. There are several reasons we went with a mixed integer approach in the first place. We have access to expertise on the subject, both from within our team and external resources, minimizing the risk to the project from trying to adopt entirely novel practices. IP formulations also tend to be very transparent with their translation of real-world information, giving users an immediate and obvious feedback after they provide new information into the model. JUMP was actually a fairly major consideration when we evaluated how easy it would be to implement the solution, but more on that later. Lastly, going the IP route meant we only have to think about how to represent the real-world issue, something that we're well placed to do within our organization, instead of committing time and resources to developing new algorithms. I mentioned just now that jump was a big factor in our decision in proceeding with a mixed integer approach. A major part of this was actually the fact that jump is built on top of Julia. Using jump in combination with Julia, it has been trivial to develop quick prototypes and experimental features, without sacrificing the robustness of the end product. During development, we never felt like we were being held back by the tools that we chose, and could move from playing around with new variables or constraints to implementing these new features in production extremely quickly. Looking a bit closer at the unique features that jump provides, we found it easy to build and manage several optimization models with different objective functions, and build the rest of the code around this feature of the model. With how flexible jump and Julia in general is, we could also explore different cuts and other optional constraints in the model at a very minor cost to development time. Additionally, since the model is built on a large amount of internal data, the easy-to-use indexing interface provided by jump made managing the different data structures within the code much easier. For example, the fact that you can index a variable by either an integer, string, a tuple containing both, or a custom struct altogether is invaluable in debugging and simplifying the way we work with our data. On a closing note, we wanted to acknowledge just how much of an asset the jump community was in developing this project for us, as well as acknowledging the general community on Discourse in answering questions and providing effective documentation in times of troubleshooting. We wanted to give a separate shout out to Oscar Dawson, who helped us tremendously both in this and several other projects. Additionally, the amount of ongoing development gives us great hope that everything will only continue getting better from here on out. Thank you.